Okay, guys, let's have a look here at this question. Illustrate on an Argand diagram the following. Okay, well that's okay. Um, 1, 2, 2, 3, I, 2I, 3I. So that's 2 over 3, so that would be there. And then 5 over 3. So that'll be about there. A third, 2 plus 5I. Okay, and then the solution of z squared equals I. That means z equals plus or minus root I. So, yeah, we'll have to do a little bit of De Morgan. Although, could we figure it out? Z squared equals I. I by I is minus 1. No, I'll have to. Okay, we'll do it by De Morgan. So, I is cos 2n pi, cos 2n pi plus I sine 2n pi. No, it's not. I forgot my 90 degrees. Okay, so we can change I into cos pi over 2 plus 2n pi plus I sine pi over 2 plus 2n pi. So De Morgan says that we divide, we power a half, and so we divide the arguments by 2. So z would be cos pi over 4 plus n pi plus I sine pi over 4 plus n pi. So z0 is 1 over root 2 plus I over root 2. And then z1 would be minus 1 over root 2 minus I over root 2 when we put n as 1. So that would be 1 over root 2 be about here. And then the other one would be about there, roughly. Yeah, okay. Right. I think that's okay. We have a little bit of a proof now to do. So let's have a look at that. Okay. Z1 plus Z2 squared plus Z1 minus Z2 squared. That's equal to modulus of Z1 squared. Oh, you know what? I think I'm going to have to put it like this. That would be the modulus of x1 plus x2 plus y1 plus y2i squared plus modulus x1 minus x2 plus y1 minus y2 I squared, like that. Let's see. Is that the easiest way to do it? No, I don't think so. Maybe. We'll see. Okay. So this would be x1 plus x2 squared plus y1 plus y2 squared plus x1 minus x2 squared plus y1 minus y2 squared. So that's x1 squared plus 2 x1 x2 plus x2 squared plus y1 squared plus 2 y1 y2 plus y2 squared plus x1 squared minus 2 x1 x2 plus x2 squared plus y1 squared minus 2 y1 y2 plus y2 squared. So that cancels with that. X1 squared, and is there another x1 squared? So that's 2x1 squared plus x2 squared, so 2x2 squared plus 2y1 squared plus 2y2 squared. So that's equal to 2 x1 squared plus y1 squared plus 2 x actually I'll group the x's together at 2, so that's 2x1 squared plus x2 squared. Should I? I'm trying to look at what I'm trying to get to at the end. No, I was right the first time. And then x2 squared plus y2 squared. So I'll just group the 1's together and the 2's together, because x1 squared plus y1 squared, that's the modulus of z1 squared, and then that second one is the modulus of z2 squared. Okay, so that's proven. Find the complex number, find complex numbers z and w such that, okay, so we have z plus iw equals 1, and iz plus w equals 1 plus I. So we want to find z and w. Okay, kind of looks like a simultaneous equation to me. If I multiply this equation by I, I'll get, put the result here, I'll get iz minus w equals I. If I add that together, I get 2iz equals 1 plus 2I. So I get z equals 1 plus 2I over 2I, multiplying above and below by I, and I'll get I minus 2 over minus 2. So I'll get 1 minus a half I for z, and then I can see here what would be the easiest way to get w. W is 1 plus I minus iz, So that's the z, and then the w would be 1 plus I minus iz. So minus iz. So that's I plus a half. I think if I multiply that by I, that's I, and then I squared. Yeah, so the i's actually cancel, and that's just 3 over 2. I kind of want to check that this is true, such that and such that. Okay, so z plus iw, that will be 1 minus a half I plus 3 over 2I. That's going to be 1 plus I. Yeah, that checks out. And then, hang on. Z plus IW should be 1. Oh, have I mixed up my two equations? Hang on. IZ plus W is 1 plus I. And then Z plus IW is 1 multiplied by I. IZ minus I. Okay. And then Z plus IW should be 1. So 1 minus a half I plus I times W. Oh, it's not 3 over 2. Anyways, that's my mistake. 1 minus a half. That's a half. So that should have been a half. And they cancel. And you're left with 1. So that checks out. Yeah, okay. And then IZ plus W, that will equal I plus a half plus a half. That's I plus 1. Yeah, okay, so I'm happy that those are the right answers. And finally, the distance between Z and 2 should be a half. So there you go, there's 1, 2, 3, I, 2I. There's 2. And the distance between Z and 2 should be a half. So I'm thinking it's going to be a circle like this of radius a half. Yeah, radius is a half. So if you're at any point here on the circumference of the circle, you'll be half a unit away from 2. So you can test it, for example, if you had, like, let's say Z equals 2.5, that's this one here, then the modulus of 2.5 minus 2 is, of course, equal to a half. So that checks out. And you could even do this point up here to test it. Z equals 2 plus I over 2. So the modulus of 2 plus I over 2 minus 2, that's the modulus of I over 2, which is a half. So yeah, that checks out as well. So it's the circumference of the circle centered at 2 with radius a half then. Okay.